Yeah, so hi everyone. We're continuing on the topic of two-way ANOVA, that is two-way analysis of variance. And as I told you that I would be splitting this into two parts. First part has already been there as two-way ANOVA using SPSS part 1. Now we are at part 2 of two-way ANOVA. The data set needs no description, as has been explained earlier in the part 1, but I'll just give a quick recap. My first variable is the ID, that is a unique identifier. Second variable is diet, that is my dependent variable, the continuous variable. And exercise and weight loss is my dependent variable, that is the continuous variable. And then my independent variables are diet and exercise. Both are categorical. So there are three types of diets and three types of exercises. Hence two-way ANOVA, that we have two categorical variables which have an effect on the weight loss. Okay, so let's go about it. So we go to analyze general linear model, univariate. Since your dependent variable is observed weight loss, put it here. Independent variables go into the fixed factors. Both of these should be nominal. Please check in the variable view that both your independent variables are nominal or ordinal, either ways. Should be categorical at the end of the day. And then we go to options. I'm going to look at descriptive stats, homogeneity tests, estimates of effect size, and significance level is at 5%. Let it be. Continue. And then we go to post hoc. So I want post hoc tests to be done for both my categorical variables and the variances assumption, that is the homogeneity assumption. I want it to be tested by 2K. Okay, continue. And then plots. I told you yesterday also that put the variable with the higher levels on the horizontal axis. Levels means categories. So in our case, thankfully, both of these have three categories. So really doesn't matter which one goes on the horizontal axis and which one becomes the separate lines. So I'll just put exercise on horizontal axis, diet on separate lines, and click add. So you should have this here. Continue. And I am not interested in contrasts. Okay, I think that's okay. I also don't want to save anything like the predicted values or anything. Click OK. So about the between subject factors, descriptive stats we've done in the previous lecture. Then we also tested the homogeneity assumption, and we were successfully able to obey one of the assumptions of ANOVA, two-way ANOVA or ANOVA altogether, that the variances should be equal across all the groups. And that was proved using Levene's test as the significance value, that is the p-value, is greater than alpha. So we were not able to reject the null of variance of dependent variable being equal across groups. And then we have this table also interpreted. Today we're going to look at post hoc and the plots. Fine. So what are post hoc tests? I told you this in ANOVA also. Post hoc means after that. That means once in your ANOVA you have proven that that there indeed is a difference across all the groups. What you can do using the post hoc test is that you can check which two specific groups have different means on them. Okay, so for that we're going to have two different tables. One would be with respect to my one categorical variable, that is diet, and second table would be with respect to my second categorical variable, that is exercise. Okay, we're going to interpret them in steps. So let's go about it. Looking at the diet, how to interpret it? So you will have combination of two diets. Do you agree with this? So the post hoc test is used to obtain the pairwise comparisons between the groups of the independent variable or the factor variable, that is in our context here both diet and exercise. So example, between the groups of diets here and between the groups of exercise. Okay. So what will be the null hypothesis? For example, I'll take a null hypothesis for any two diets, say diet 1 and diet 2. So null hypothesis would be there is no significant difference between the mean weight loss in diet 1 and diet 2 following the participants. So basically following participants. So all those participants who followed diet 1 and diet 2 showed no significant difference in the mean weight loss. Okay, that's the null hypothesis. Alternative would be there is a significant difference, right? So similarly, the combinations can be, since I have three diets, 1, 2, 3, what are the combinations? Diet 1 versus diet 2, diet 1 versus diet 3, and diet 2 versus diet 3. Now, this particular table is going to perform all those multiple comparisons. But the only thing is that each of the comparisons appears twice. Okay. So just to make the design more beautiful, I would say, it just appears to be coming twice. So we can see now, let's start interpreting. Okay. For diets, we're going to have two different tables. This is for all possible combinations of diet. And this one is for all possible combinations for exercise. Okay. So it says that yeah, so we can see that using the 2K HSD test. So what is the test we're going to use in order to test whether the whether to test that null hypothesis which I just told you, the 2K HSD test. It is also known as the honestly significance difference test. So if you were to define 2K test, how would you say? So 2K test allows us to identify which sample means are statistically different from each other. Okay, so we can now know exactly which means are not equal. Okay, so we would have the difference in weight loss, that is my dependent variable, between no diet and Atkins diet. Atkins is a type of diet. So difference in weight loss between no diet and Atkins diet is 1.46 kg. And this difference is statistically significant because the p-value here in the significance column is 1.8%, which is way too low than alpha of 5%. So I'm rejecting the null hypothesis of no difference. Okay, so there indeed is a significant difference between the weight loss observed after doing no diet and doing an Atkins diet versus doing an Atkins diet. Okay, similarly, I'll interpret the next comparison. The difference in weight loss between no diet and vegetarian diet is 3.47 kgs approximately. And this difference is statistically significant as p-value is 0, and we reject the null hypothesis at an alpha of 1% or 5% because this is 0. It's highly significant. Okay, highly significant values are also shown by asterisks. Okay, that's just another way to check whether they are significant or not. Likewise, we can perform the last comparison, that is between Atkins and vegetarian. Okay, so difference in weight loss between Atkins diet and vegetarian diet is 2 kgs, and this difference is also statistically significant as we reject the null hypothesis because p-value is 0.001. Okay, so that way this was about the multiple comparisons that we were performing for each of the diet combinations. Okay, similarly, in a similar fashion, I'm going to look at the multiple comparisons for the exercise combinations, as simple as that. Okay, so the difference, the mean difference or in the weight loss, we also call it the mean difference. If I have been saying the difference, please correct it. It's the mean difference in the weight loss. Okay, the mean difference between no exercise and a 30 minutes per day exercise is minus 0.289 kgs. Not much. And is it significant? No. P-value is 0.852, which is way too high than an alpha of 5% or 1% or any alpha. So we're not able to reject the null of no difference. Okay. So next, the mean difference in the weight loss observed after no exercise and a person exercising 60 minutes per day is 6.281 kgs. You see that? So indeed, you should be exercising 1 hour every day. And that is statistically significant as p-value is 0. Way too low than alpha of any 1% or 5%. Then the difference between the mean difference between the weight loss observed between 30 minutes per day exercise and 60 minutes per day exercise is 5.992 kgs. That's also good. Okay. So is it significant? Voila, it is 0.00. So p-value is again less than alpha. So I can see that there is indeed a significant difference between the mean weight loss observed after doing 30 minutes exercise per day and 60 minutes exercise per day. So I think the conclusion is you should be exercising if you haven't. Okay. So that was about the post-hoc tests. They allowed us to make multiple comparisons between the sets of groups. Now, lastly, let's look at the profile plots. Remember, we used to have mean plots in one-way ANOVA. Similar fashion, we also have profile plots over here. Okay, so each line in the profile plots is all the more same as we can see over here. They follow the same pattern except the Atkins one. So what do we have over here? Remember, I put exercise on the horizontal axis. So that's showing up here, none, 30 minutes per day, 60 minutes per day. And I said that I need separate lines for the diet. So these are the separate lines for diet: vegetarian diet, Atkins diet, and no diet. Okay. And there are two key things which you should be understanding. If the profile plots show that lines are all the more parallel and follow a similar path, that means that there is no intersection of lines. Basically, there is no intersection of lines, as you can see. That means the interaction effect of both the factor variables or the categorical variables is not present. Okay, what I'm trying to say is that in the earlier lecture also I taught you that this particular interaction of diet and exercise is not present in our model. Okay, if it were present, firstly, it would have been statistically significant. It did not come out. Secondly, there should have been an intersection of the lines. So that would have meant that indeed is an interactive effect. Okay, it's not there in our model. So you are doing one type of exercise and doing another type of diet. Both don't have an overlap on each other with respect to, meaning that effect of exercise does not depend on the type of diet you follow to an extent. Okay, that really doesn't matter according to the interaction. Now, interpreting this, I can say that after 30 minutes per day exercise, each of the weight loss curves, so these are the mean weight loss observed, okay, and they start rising, steeply. So mean weight loss has actually risen after 30 minutes per day exercise in each of the diet formats, okay. And what I see is that vegetarian diet leads the way. So I think it's time to turn vegetarian. So vegetarian diet is ahead of both the diet forms, and we see that the higher weight loss is observed among the vegetarian diet, okay, the vegetarian diet doing people. So I think that's all about two-way ANOVA, which we were to explore, and that's it. So watch both the videos together. The first video we watched first before this particular video. Thank you for watching.